This is going to be a recording of the geometry FSA practice test. Depending on how long this goes, I might make it into two separate recordings. So let's get started. And I got this from the FSAassessments.org website. It is the Florida-based end of course exam for geometry, just to give it some context, but it could be helpful for other states as well. This is the paper-based test. You might be taking the test on the computer, so follow whatever instructions are listed. They do offer a reference sheet, which is handy to look at. I know that we'll be using some of these formulas a little bit later. So that is provided for you. We're going to start with session 1. Okay, let me make sure. So this one only has one answer. We're looking for angle BCD. Okay, so I am going to BCD is this angle right here, okay, in blue. Because you start at B, you go to C, and then to D. So we're looking for that little inside angle right there, okay? We know that the two vertical up and down lines are parallel, and then there are two other lines that are parallel. So that tells us quite a bit about the angles. For example, I know that angle B and angle D are going to be the same, and that angle C and angle A are going to be the same because of the way that the lines are parallel. And we know that angle ABD, so okay, let me also, so we're looking for this blue one. So that's going to be right there, okay? Same thing. So hopefully that helps, seeing all the different angles that are the same. So we know that angle ABD, that's this, what color should I make that? I'm going to make that orange. ABD right here is orange, okay? So ABD is orange, measures 3x plus 4, okay? And angle BCD, so that's the blue angle that we're actually looking for. So BCD is the blue one, measures 6x minus 8. And angle EDF, so that's the D down at the bottom, which I did in pink, EDF right down here, is 7x minus 20. And we know that these two are the same. And then we have our orange one, which is 3x plus 4. And then we have our blue one, which is 6x plus 8. And if you look at that, it makes 180 degrees, right? So right here, this whole thing, all those three angles together give us 180 degrees, half a circle or you know, like along a line. So if I were to add these up, because I know it's going to equal 180. So 3x and 7x is 10x, plus 6 is 16x. And then negative 28 plus 4 is negative 24. We're going to add 24 to both sides. So 16x equals 204, I think. And then we're going to divide both sides by 16. So when I do that, I'm going to get x equals 12.75. That is not our answer. We have to do one more step. So remember, we're looking for angle BCD, which is the blue one right here. Okay, so, and that was 6x minus 8. So I'm going to plug in 12.75 for x and then figure out how much it is. So when you multiply by 6 and then subtract 8, you get the answer, which is 68.5. So that is the answer for the first problem. Oh, I forgot to clear. Okay. So for this problem, we have 3 castles, and we have to figure out what what shapes they're made up of. So this first one, the 2 towers have tops that are cones. I'm going to make cones orange, like an upside down ice cream cone. And a cone has like a circular base, right? And I know this because the line, like the roof line, is kind of curving like a circle. So that means the base has to be a cylinder, like a soda can or a large oatmeal container. So I'm going to make cylinder this green color. Okay. From the side, cylinders just look like rectangles, but they have the base of a circle. So that's a cylinder. There are no pyramids in it because a pyramid would have a square base or a triangular base, and a rectangular prism would be like a box. So if we look at the second castle, it doesn't have any cones, but it does have cylinders, right? The little towers are circular. You can tell by the way that they're shaded. So it does have cylinders. It doesn't have any pyramids that I can see, but it does have rectangular prisms. Like the main castle is a rectangular prism. So think of like, you know, like a box. Pretend that my box is not crooked. Okay. And the third castle is super fancy. So if I look at the front bottom part, it looks like it's rounded. So I think that that is a cylinder down at the bottom here, or rather 2 cylinders, right? Here and here. And because these are cylinders, kind of like a cake, the thing on top of it is going to be a cone. So this little triangle thing right here is a cone. And then the rest of it, the rest of the building looks like a rectangular prism. So there's, you know, this base prism here, base box, and then like another one here. And you could even say like these 2 towers are. So what does that make the triangle on top? If it's on a square, that would make the triangle on top a pyramid. because it has a square bottom. So anytime you have I don't know if I could effectively draw a pyramid, but it has a square base to it. Okay, so there's your different shapes in buildings. Okay, so here we have a circle, and there are two chords intersecting the circle, but they don't go through the middle. If it did go through the middle, the arc on the outside would be equal to the angle in the middle. But since it doesn't go through the center of the circle, um, we have to use a formula. And the formula is whatever the measure of the angle on the inside is. So this angle right here is 4x, right? 4x degrees. So the inside angle, 4x, equals half of the two outside angles. So um, the first angle is 120, and the other angle is 2x. So we're just taking the average of the outside angles, 120 plus 2x, and that's what the inside angle is going to equal. So 4x equals half of 120, which is 60, and half of 2x is x. Subtract x from both sides, so 3x equals 60. X is going to equal 20. And it's asking what is the degree measure of AED? So AED is right here. We're not looking for what 4x is, we're looking for what that orange angle is, AED. Okay, so we know that a circle is how many degrees? 360, right? And we know that um, these angles are the same, like 4x and 4x and whatever the two orange ones are. So we could say that 4x is how many degrees? Let's plug in 20 for that. So 4 times 20 is 80. So we know that this is 80 degrees and this is 80 degrees. Okay, so 80 plus 80 is 160, right? And we know that the circle has 360 degrees. 360 minus 160 is 200. So the two orange angles equal 200. So if we divide 200 by 2, that gives us one of the angles. So that's going to be 100 and that's going to be 100. So the answer for this one would be 100. Okay, so here we have a triangle SRT on this graph. And we have to choose the correct equation or phrase to fill in the paragraph. So there's going to be more than one answer. There's 3 different answers for this one. Okay. And let's see. It's going to be reflected twice. And it's going to be the same thing as a translation of 4 units to the right and 4 units up because the lines are what? So I'm just going to draw it on the graph, 4 units to the right and 4 units up, so you can get an idea of where it is. So if I go 4 units to the right, Ooh, I forgot to turn on my pen. Okay, 4 units to the right. 1, 2, 3, 4. 1, 2, 3, 4. Puts it right here. And then 4 units up. So my new shape is right here. Okay, so we went 4 units to the right and then 4 units up. And they want to know um, how it was moved, how it was reflected. Okay, so if we look at the answers, the first 2 answers have just numbers like x is 4 and x is 6. So if I were to draw a line at x is 4 right here, if I were to draw a line there and reflect the shape across it, it would be like this. And if we look at that red triangle I just drew, there's no way we could reflect it to the orange triangle that it has to be into. So that is not um, going to work. And I'm guessing it's going to be the same thing for x is 6. So if I drew a line right here where x is 6 and I reflected the triangle across, then it would be right here. And there's no way that we can reflect this red triangle over to where the orange triangle is. So that's not correct. And the next option was y equals negative x plus 5. So let's try that one out. Oh, I forgot my pen. Y equals negative x plus 5. So this one has a y-intercept at plus 5 and the slope is -1. So it's going to go down 1 over 1, down 1 over 1, right? So this is this line, and if I were to reflect it here, I would get this red triangle. Is there any way to go from the red triangle to the orange triangle by flipping it over a line? I think the line would have to be right here, but I don't think that's an option in the second answer. So let's see. It's either 10 or 12 for the intercept. So that is not an option. So our answer for the first one is going to be, oops, it's going to be D. So D says, let me look at D again. I wish it fit all on my screen. D says y equals negative x plus 6. Okay, so I'm going to put my line in at, okay, y equals negative x plus 6. So plus 6 is the intercept, the y-intercept, and the slope is negative 1. So I know that it's going to look like this. So this is our line of reflection for part A, okay? And I'm trying to draw this, but I don't think I'm doing a very good job. I feel like I'm missing something. Oh, I had the point wrong. Okay, so here's our first reflection, okay? And now we're going to reflect it across another line. So how about blue for this line? I'm trying to draw with the eraser. Okay, so here's the line we're gonna reflect it across, right? So see how these are like even? If I were to like flip it over, the red triangle would become the orange triangle. So this blue line is going to be y equals negative x because it has a down 1 over 1, has a negative 1 slope, and the intercept is 10. So that is the second part of the equation. And if you look at the red line and the blue line, what do you notice about them? They're always how many spaces apart? 4 spaces apart. So they're never going to cross, they're parallel. Okay? So for the answers, we would choose that y is equal to negative x plus 6, y is equal to negative x plus 10, and that the lines are parallel. It's 4 units up, 4 units to the right, and that's how the lines were consistent. They stayed that distance apart the whole way. It means they're parallel. So that's how to answer that one. If you haven't noticed, I think that drawing really helps with the test and solving the problems. So make use of your scrap paper or your whiteboards and draw things out. Helps your brain function. Okay, so for number 5, Johnny wants to find an equation of a circle with center 3, negative 4, and a radius of 7. He uses the argument shown. So think about the equation of a circle. Um, it is this, I think. Okay, so for the x, it's going to be x minus 3 squared, right? Because your x is positive 3, so you subtract it. So that would be A. And then for your y, it'll be y minus negative 4 or y plus 4 squared. So that would be D. And has a radius of 7, so 7 squared. Now, for the last part here, the total distance, what can be used to create an equation that shows the relationship? So what does this circle equation remind you of? And we have basically a squared plus b squared equals c squared. So the equation of a circle is just like the equation that we use commonly for triangles, the Pythagorean theorem. Pretty cool, huh? So that would be the Pythagorean theorem. All right. And if you had no idea about the formulas, think about a circle, and let me just draw a circle really fast. Think about a circle, right? And the center is the radius. And if you're picking like any 2 points on the edge of the circle and connecting them, what shape do you have? A triangle. So that's why you would go with the triangle formula instead of the other ones. Okay, so number 6. Here we have a pentagon and there are different transformations. Make sure it's on this page. Okay, so first thing, select all the transformations that can make it go onto itself. So all means more than one answer. That's a clue. Okay, so probably 2 or 3 answers. Now, how do you pick when you have no idea? Right? Um, the end goal is to have the pentagon like end up on top of itself with like the points lined up where they currently are. So let's look at A. Um, says a reflection across line EK. So line EK is, well, you get the idea, through point E and K. And if we were to like fold this in half or reflect it, basically this would be G, this would be H, this would be I, this would be F, and this would still be E. Okay. And then it says 180 counterclockwise rotation. So if it were 360, it would be like all the way around, right? But it's not. So that would be 360. 180 would be to like right here. Okay. So then my E would be pointing in the other direction. I'm going to try to draw this the best I can. So now E is here. I, H, G, and F. And then it says a reflection across a vertical line through point K. So if we draw a vertical line through point K, it's going to look like that now. And we're going to switch like we're reflecting. So now E is over here, G is over there, H is here, and I is here. And if you look at the original letters, that's good. So A is definitely an answer. And it will take some drawing. I mean, maybe you're like super good in your brain of doing this, but I have to draw it out. So to visualize it, because that's how my brain works. So A works. So now we're looking for 1 or 2 more answers that could be true, okay? So let's look at B, a 90-degree counterclockwise rotation, so about point E. So first, oops, I'm drawing with my eraser. If we start right here, 90 degrees is just going to be to right there. And then a reflection across. So I'm going to try to draw, like I said, I'll do my best to make it look like it should look. Okay, so this is I, this is H, G, and F. That was the first step. Okay, so 90-degree counterclockwise, reflection across FG. So FG is right here. That means it looks like this now. HIE. And a vertical translation. So that means we'd be moving it up. So it's not right on top of the thing, and F is on top, whereas over here, I is on top. So this one is not a solution. Okay, let's go to C. A reflection across line FI. So here is FI, and we're going to reflect it. So now we have point E, H, and G. So that's this part. And then there's a reflection across line GH. So here's GH, and we're going to reflect it like this. So E is now over here, F is now here, and I is now here. And 180-degree clockwise rotation about point K. So remember K is in the middle. So if we were to rotate this, what is it, clockwise, 180 degrees. So we start here and we go halfway around to here. What would that look like? I think E would end up being over here. Well, somewhere over here. And that does not match up with what should be over there, which is G. So this is not an answer. Now, if I was crunched for time, I could take my chances and say, well, D and E are going to be correct. Because we know that there's going to be at least one more correct answer. So if you want to take your chances, you could do that. But I will go ahead and explain these just to show you. So let's see. D says a reflection across vertical line through point K. So I'll make that blue. So point K, vertical line, a reflection across it. So now we have I is over here, H is over here, G is over here. This is F, and this is E. Oh, that's busy. Okay, 180 clockwise rotation about point K. So we're going to start here and rotate it halfway around. So if I do that, this will now be I. This will now be H. This will now be G. So now it's like this one again because we rotated it. This will be F, and what am I missing? So E. I think I messed up. So E. This is F, and this is G. And this is H, I think. Oh my goodness. I don't know. As long as I have my I correct, let's just stick with that one. Okay. And then a reflection across line EK. So EK is right here. And if this I were to be reflected straight across to right there, I get my original I. So that's a strategy you can use instead of trying to figure out all the different points, like stick with one, like I did with this I, and that should be simpler and not as confusing, but it does show that it worked. Okay, now let's look at the last one, E. Clean this up. Okay, a line, 180-degree clockwise rotation about point E. So here we are at point E, and well, let me say 180 would be like this. So G, F, H, I. So that's the first part. A reflection across a vertical line through point E. So our vertical line through point E, that's up and down. So now it will look like 1, 2, 3. Ooh, that got wonky. So now it's F, G, H, and I. Okay, and then the last one says a reflection across a horizontal line through point E. So here's a horizontal line, I think. And if we were to reflect it now, I'm trying hard to draw this nicely, but I don't know how well I'm doing. So this is F, that's G, this is H, and this should be I. I don't think that is an answer, but my drawing is a little bit off on that one. So double check. If anything, you would get partial credit. Well, if I were taking it and I got it wrong, I would get partial credit because I know for sure A and D are answers. All right, so for this problem, it says Alejandro cut a circle with circumference C and radius R into 8 congruent sectors and used them to make the figure shown. So imagine like the original circle is like a pizza, right? So there's 4 slices. Here's your 8 slices. And he took these 8 slices and put them back together again to look like that. which is kind of weird, but um, imagine serving a pizza like that. It would be strange. And put like, you know, toppings on it. um, I like jalapenos on my pizza. I like spicy things. Um, okay, so this shape kind of looks like a parallelogram, which is a quadrilateral, right? Okay, now we need to figure out all the statements that are true. I probably should have scrolled down a little bit before. Okay, so all the statements means what? That's right. It means there could be more than one answer. Alrighty. So let's look at A. The height of the parallelogram is approximately equal to the diameter. Is that correct or no? Well, if you remember what a circle looks like, the radius starts at the center and it goes out. So like this is the radius. So the height is equal to the radius. The diameter goes all the way across. And that is not what we have going on, right? So that's the diameter all the way across, the radius is half. So we know that the height is equal to the radius. So A is not an answer. Um, but D is. The radius of the circle is approximately equal to the height. So the radius and the height are the same thing. So that's one answer we got. Okay, let's look at B. The area of the parallelogram is approximately 1/2 C times R. So C is the what? Is it the area? No, it's the circumference because it says it up here, circumference. So remember circumference is all the way around a circle or 2 pi r. So, and a parallelogram is just base times height, or area equals base times height. Well, we know that the height equals the radius. So we could substitute that in. And then the base right here, like the top and the bottom are the circumference of the circle. So half of that will give us the base. So half of the circumference gives us just the base, and that is what they say. So B is also an answer. Okay, the length of the parallelogram is approximately equal to the circle's circumference. Well, we already know that the length, the base, is half of the circumference, so that is not correct. And E says the area of the parallelogram is approximately 8, which is how many slices there are, times 45 over 360. If you didn't know what that was, think about a circle. How many degrees are in a circle? 360. How many degrees do these little pizza slices have? 45. If you were to divide 360 by 8, you would get 45. So each one of those little angles is 45. So, and you have to use like area of a circle is pi r squared. Um, so 45 over 360 pi r squared. If we look at just this part, 8 times 45 is 360. 360 divided by 360 just cancels out. So we're left with pi r squared, which is the area of the circle. So this is also an answer. We have another fun shape. Okay, Evelyn is designing a pattern for a quilt using this polygon. Equergeship. I think that's what that says. Equerfergship. Okay, maybe it's like a frog ship. EQ frog ship. All right. Um, so we have this shape and there are answers down here. So she transforms the EQ frog ship. So the image of E is at 2, 0, and the image of R is at 6, -7. Which transformation could Evelyn have used to show that EQ frog ship and its image are congruent? Well, we're only looking for one answer here. So that's good to know. Which transformation? That just means one. Um, I'm going to put a point at 2, 0. So E is now at 2, 0. So that's here. And R is now at 6, -7, which is here. So if I were to try to draw this, you don't have to draw all of it. I'm just doing it for fun. Well, I'm going to stop drawing because it's wasting your time. Okay, but what we really need to know is it looks like we're shifting it down and to the right. Yeah? So if E starts here to get to the x-axis, how many down are we going? Well, it's at 4 and we're going down 4. So down 4. And same thing with R. We're starting here at -3 and we're going to -7. So that's -4. So it's down 4, right? And then I could look to say, well, now it's going from -5 over to 2. So that's +7. Let's check over here. We're going from -1 to 6. So that's +7. So down 4 over 7. And which answer is the same as that? It was translated right 7. So I could say right 7 and down 4. So B would be the correct answer. All right, number 9. Catherine uses triangle ABC where DE is parallel to AC. So, oops, these two lines are parallel, okay? Um, and she wants to show that the two sides are divided proportionately. So she's going to make a proof. I'm going to scroll down. Okay, so we want to know, let's look at the triangle here. We want to know that, and a proportion is what? Think about when you write a proportion down, you're going to use like a colon, like 2 dots, or you're going to use a fraction or the word 2. So let's think about our sides, okay? we have dB or BD. I'm just going to put them, and that is going to be proportionate to BE or EB. I don't know. I'm just writing them down on both sides. And then the other two sides are AD is attached to the BD, right? So it could be AD or DA. And then EC or CE is attached to the EB. Okay? And these are proportions, so it's going to look like a fraction, right? And it says, which statement completes step 8 of the proof? So if I look at my answers, I'm going to eliminate A and B because they're not proportions. Remember, we're looking for a proportion. She's trying to prove that they're proportionate, so it's going to look like a fraction. So which one of the two fractions remaining, like either answer C or answer D, gives us like the little variations of the sides that we have? So we know that side BD and AD have to be together. So that's going to be this one. And that sides EC and BE have to be together. Well, they had it like this. And then they put the other part of the thing on the bottom, which is okay because they were still, matchy-matchy. That's how I like to say it. Matchy-matchy. Okay. Okay, number 10, a rectangle and a horizontal line are shown, and it's going to go around the line. What would the shape be if we rotated the rectangle around the line? It would give us a cylinder, a sphere, a rectangular prism, or a hexagon something. um, so the answer clearly would be A. All right. Okay, so this question has 3 parts. Triangles PRQ and TSR are shown. And for part A, select all assumptions that must be made about the two triangles to show AA similarity for triangles. What does AA similarity mean? Well, with triangles, you have sides and you have angles. So AA means angle, angle. We need to show that two sets of angles are the same. Okay, so if we know we have to show that two sets of angles are the same, our answer is going to have angles in it, right? So I know for 11, it's not going to be A or B, okay? Because these are not angles, these are sides. So C, D, E, and F are angles, and it says select all to show angle, angle. So I'm going to color coordinate. So for S and Q, could be the same. Let's look at, so that's this, I don't know, red or pink color. And let's do purple for this one. S and P Do you think S and P are the same? I don't know. S and Q look more similar to me. T and Q, let's do that in orange. I don't think that that would work. If you were to flip the triangle like over onto itself, then I think that this one and this one are going to be the same, and this one and this one are going to be the same. It's like flipped and rotated. Okay, so the last one says angle SRT. So that's this angle, and angle QRP. Oh, sorry. This angle QRP. So those ones are definitely the same. I know for sure this one. And I think that a better one would be the S and Q. Because it has to be like, it's like flipped. Or if you were to like rotate the entire thing, like here's Q and here's S. If I were to rotate the entire thing, the angles would be like the same. Okay, so let me erase all this. Got kind of messy. For part B, which transformations should be applied to show similarity? So if we were to look at the rest of the answers, two of them say rotate and two of them say reflect. Okay, so rotate means you're spinning it and reflect means you're flipping it. And it's, well, all of them are about point R except for the last one, which is about point P. So I know it's not going to be D. Like about point P isn't going to work. So it's either A, B, or C. It's either going to be rotated or reflected. And if I were to guess, I would say rotated because there's two of those left. And then it's translating or dilating. So like, let's say that we're going to rotate it about R. So if we did that, then we'd have a little triangle, right? Are we going to translate it and move it up or over? Would that work? No. So what would work is if we made it bigger. So if we dilated it and made our little triangle now a bigger triangle, like Alice in Wonderland when she eats those little tasty cakes and she gets really big or she gets really small. She's basically dilating. She's getting bigger or smaller, that's dilating. Or when they put those drops in your eyes, you know, your eyes get like really big so the eye doctor can see in them. That's dilating. So we're going to rotate it around point R and then dilate it to make it bigger. So for part B, that would be answer C, rotation about point R and dilation. And it gives us a scale factor, but you get the idea. Okay, now there's one more part to this question. This is a long one, right? And it says, which conclusion can be made from the transformations? For each box, fill in the bubble before the option that is correct. So we have 3 answers. Okay, so applying what, and remember we were doing showing that angle is to make the triangle similar. So the key word is similar, and the definition of similarity in terms of similarity transformations. So I would go with D. Think about what they're asking for, right? We use transformations, right? And the triangles were similar, okay? Showing that triangle PRQ, so let me scroll up and look at it again so I can draw it really fast for you. PQRST. I forgot already. I think our, oh my goodness, I have to look at it again. Okay, S is on top. Okay, so triangle PRQ is similar to triangle P and T, so it should be TRS, because we're going like this way and then this way. So I'm going to start opposite of P and go T to R to S, because T and P are what are similar, and S and Q are what are similar. So TRS would be answer E. And then the last question, thereby showing that, remember it wanted the AA, which is angle, right? So how would we prove the angle? Two congruent angles. That's all that we needed was AA, 2 angles. Okay? So that is enough, sufficient to prove similarity of 2 triangles. All right, number 12. We have this triangle on the graph, and they transform it to RTV with apostrophes by multiplying it by 0.2 centered around the origin at 0, 0. So that tells me 2 things, that 0.2 is like 1/5, it's 5 times smaller, right? So they shrunk it by 0.2, they made it smaller by 5, they divided each side by 5 and made it smaller, and they moved it around the origin, okay? So they're shifting the center of it to the origin. Now, it says select the 3 equations that show the correct relationship between the 2 triangles based on the transformation. So we know that we're looking for 3 answers. Alrighty? Okay, so the big triangle, hold on just a second, let me write down the triangles. The big triangle is RTV. So I'm going to write down big, like the big original triangle is RTB. The small one is R apostrophe D T apostrophe B apostrophe. And this one is 0.2 of the big one, and this one is 5 times as big as the small one. All right, so let's look and pick our 3 answers. Side RV on the big triangle is 5 times side RV on the small triangle. That is true because the big one is 5 times bigger. So A is an answer. If we were to divide for B, if we were to divide the small side by the big side, the square root of 26 is probably what the side measures. This doesn't match up. This should be the big side, and this should be the small side. So this one is not correct. And that should be the small side because it's multiplied by 0.2. Make sense? Okay, so for C, we have 0.2 times square root of 10 times the big side equals the square root of 10, the small side. So C is correct because you're multiplying 0.2, right? 0.2 times the length of a big side to equal the small side. Let's look at D. The big side equals 0.2 of the small side. That is not correct. That would just make it a smaller side. So you're multiplying, remember, you're multiplying 0.2 times one of the bigger sides, and you're multiplying 5 times one of the smaller sides so that they equal out. So for E, we have 0.2 times the small side, and I know that's not correct because it's 0.2 times the big side. And this last one, if the big side is 34, the small side is 0.2 times. So this is the big side, this is the small side, and that matches up over here. Big on top, small on bottom. So that would be the last answer. Okay, so just pay attention to the different proportions that the problem is giving you. Like this problem gave us 0.2 as like the smaller side is 0.2 of the big side, and that's what all of the answers were based off of. So that was the end of part 1, and because it has already taken me quite a while, I'm going to make a second recording for part 2 to go over the remaining questions.